In this video, I will go over homework 1 for the logistics course. This homework is a mini case that is broken up into different questions so that we can see how certain logistics decisions are to be made. It's a very realistic scenario. Companies do this sort of work all the time. So let's go through it, and we will be using Excel to solve it. Now, you may have been provided an inventory cost calculation Excel worksheet on Canvas. That makes it faster to do this, makes it easier. You can just plug in the data from here. It does the calculations for you. However, you should be able to look at formulas in the slides or lectures and build your own Excel calculation. So I'm going to start from scratch without any worksheet and build the calculations to demonstrate you how to do this in Excel as well. Because for every possible calculation, you may not have a worksheet provided to you, or even if you have a worksheet provided to you, the situation given to you may not map exactly onto that worksheet, and so you may need to update it or change it slightly. And so if you know how to do this in Excel from scratch, you can do all of that. So here is the scenario. We are working for Twiddly Toes. It's a shoe retailer, okay, and we're going to import shoes from China. Okay, the shoes cost an average of this much, and we have James, who's a logistics analyst, and he's going to pick which transportation route to take from China all the way to our distribution center in Syracuse. Okay. The shoes will be ordered in batches, but we need to figure out which route to take, and there are two options. Okay. The existing route, which the company has been using before, is referred to as Route 1. It costs on average $2 per pair of shoes. James is new to the job and he wants to make his mark. So he has searched and found a new route that was going to be called Route 2. That is much cheaper. In fact, it costs only half the amount of the existing route at only $1 per unit. James is ecstatic. This could be his chance to cut transportation costs in half in all imports from China if the new route is used. This could be a career-defining move. Now, from the lectures, you may have learned that we cannot take logistics decisions in isolation. This seems to be a transportation decision, whether you send product to Route 1 or Route 2, and Route 2 is much cheaper, right? So if you want to save on transportation costs, you would go with Route 2. But logistics has trade-offs. If you are saving money in one place, sometimes you increase costs in a different place. So to make a holistic decision, we need to factor in how the new route will affect our inventory costs, and then make a conclusion whether the savings are worth it, whether the savings on transportation costs are more than any potential increase in inventory cost, or when total cost is considered, maybe Route 1, the existing route, is still better. So we have to check that before we do this. So thankfully, James took a logistics class with me, and he remembers that he studied the trade-off between inventory cost and transportation costs. Okay. He texts his friend that he's wrecking it at the new job, and he decides to quickly check the effect of using Route 2 on total cost, which is inventory and transportation costs combined. He gathers the following information. So this is the data we're going to use to do our calculations right here. So when we do calculations in Excel, it is better to build a structured type of Excel sheet. So if you go back to the Excel sheet a few weeks down the line, maybe you're preparing for the exam, you can see exactly what things mean. So we're going to add some labels, add some comments, or we're going to structure the Excel sheet so any reader can see it and know what's happening. Okay. So the basic structure that we often do for these sorts of calculations is we make a data section, data/inputs section, okay, which is where we will write down all the inputs to our calculation. Inputs is data given to us So for example, we may need demand data, and so maybe marketing tells us this is the demand data. So inputs are things which are not the result of our model. In fact, they are required information our model needs to work. So that we'll put all the inputs together up here. Then somewhere down there, we will have our model slash, computation. Okay. And then whatever the outputs of the model are, we will put them, here, so that anybody who wants to see what is the output of the model, just scroll down to this section and all the output is neatly given here. So inputs, model slash computation, and output is a basic structure that works for many such calculations, and it organizes your model nicely. Anybody reading the Excel file can see kind of what's happening. Your formulas will go here. The formulas will depend on information here. Okay, and then whatever is the final output, we will replicate it here, so we can also just see the output right here neatly formatted instead of having to worry about the computation if that is what we want. Okay, now one way we can make the input section is just go through this and just write the input in the order it shows up in the question. That may not be ideal. Some inputs are about demand, some are about transportation time. So we can club them based on what the input is about. That makes it easier for the reader. So let's look at demand data first. Okay, so marketing is giving us all this demand data. So we expected daily demand is 1,000 pairs or 1,000 units, because a pair of shoes is 1 unit. So we write small d is what we use for demand. That's 1,000. It's units per day. Okay, that's our demand, daily demand. Okay, so that's small d is sometimes called daily or weekly demand, and in this case it's units per day, so it's daily demand, right? So you can put that in if you want. Yeah, maybe we should daily or weekly demand. Okay, so that is and for us it's units per day, so it is daily demand. Okay, let me just take this out. Okay, then we expect to sell 6 days a week for 52 weeks in a year. So our number of days that we have in a year in which this daily demand occurs, because if business is closed, we don't really sell 1,000 units, right? On average, we sell 1,000 units on days the business is open. So number of days this daily demand is applicable to is 6 days per week times 52 weeks. And the asterisk, which is Shift 8 symbol, is a multiplication symbol in Excel. So 312 days is this demand applicable to. Now we can calculate annual demand based on that data, right? And that is going to be daily demand times number of days, and that is your annual demand. That's units per year. Okay, why am I doing this calculation? This is supposed to be an input section. Well, I need annual demand for some of my formulas, and I need daily demand for some of my formulas. So I need input of daily and annual demand. This is kind of like an intermediate calculation. So sometimes you can make an intermediate calculation section, put it here. I think of it as just processing the input to make it more usable, and some input processing, basic ones like this, I can do up here in the input section. What I'm going to do is I'm going to shade this maybe as a green color, where you put in the input, and intermediate calculations are going to be gray. So this is not an input. Don't change this cell. Green cells you can go ahead and change, right? So I'm going to do some color coding like that. Standard deviation of daily demand is 350. So I like to put it right under the daily demand because often formulas which use demand also need the standard deviation. So I want them together because this is the standard deviation of this number. Because this number is not a fixed number, it's changes up and down. On average, it's 1,000, and the standard deviation is 350. So this is again, units per day, standard deviation of demand per day. Okay. Okay, so that was the demand data. Then we have cycle service level of 95% and holding cost. This is all inventory data. So after demand data, let's make it a nice color, make it bold. Now we're gonna have inventory data, okay? And here we have cycle service level, cycle, let's put holding cost first. We're gonna put H holding cost, that'll be dollars per dollars per year, okay? And that is $0.3, okay? So what does this mean? This means that if you have a $1 of inventory and you hold the $1 of inventory for a whole year, then you'll have to pay 30 cents in holding cost to store that inventory in a warehouse. You know, there's warehousing costs and so forth, or store wherever you store that inventory. Sometimes the question will say holding cost is 30% of the value of an item. So 30% means you pay 30 cents on the dollar. So 30% can be converted to $0.3 per dollar per year. Okay. Sometimes it'll just say $0.3 per dollar per year. So if we say 25%, 50%, 25% becomes $0.25 per dollar per year, 50% becomes $0.5 per dollar per year, because 50% of a dollar is $0.5 and so forth. You could also keep it as a percentage. You could put in like 30% here and make it like percent, and then you could use that too. So in either case, we're going to multiply this by the value of the unit, because if it's $0.3 per dollar, and if a shoe costs 38 or 40 or whatever dollars, then we're going to multiply the 0.3 by the value of the shoe to figure out how much it costs to store one shoe in inventory for 1 year. So in the end, it's going to get multiplied by C, which is the item cost, right? Whether it's 0.3 or 30%, it's going to give you the same thing. 30% of 40 is the same as 0.3 times 40, right? Because 30% of something, you do 30 over 100 times that something. Right, so 30% of C is the same thing as 0.3 times C, right? Where C is the cost of the item. So either way you express the holding cost, it's equivalent. Okay. If something is out of stock, we have a lost sales cost because we lose money on not making that sale. It's about $1.20. So that's K in your formulas in the slide. That's the lost sale cost, right? And that's $20 per unit. So each unit that you have a lost sales on, you lose $20. Okay. So and we have our lost sales cost. Then we have our cycle service level. Let's call it CSL. So let's call it CSL. And in brackets, we write cycle service level. That's 95% or 0.95. You can format this cell as percentage and show 95% here. Remember that when you format cells, the display value can be based on the formatting, but the real value is the number you entered, 0.95. So if I multiply this cell by 2, I get 1.9, which is 0.95 times 2. I did not get 190, which is 95 times 2, because the value behind the cell, the actual value is 0.95. I'm just using this formatting button to display 0.95 as 95%. So the value behind is still 0.95, which is what we want. We want the 95% to be 0.95. Okay, and then just like I did with demand, I know that the cycle service level is not directly used in the formulas, but the z-score associated with the cycle service level is used. So I will compute the z-score, and the formula to convert cycle service level as a fraction, as a number between 0 and 1, like 0.95, 0.99, 0.85, 0.93, 0.97, whatever it is norm.s.inv, and you give it the 0.95, and that becomes 1.64485. We want to use this exact value and not round it up to 1.65 because rounding to 2 decimal places will introduce inaccuracy in our calculations. You want to keep at least 4 decimal places if you are doing it by hand, but you're doing it in Excel, so you don't care. You can keep all the decimal places in Excel. There's no cost to you. Okay, so that is my inventory data. Okay. Now let's look at the transportation data. Okay, we also have it's given right here. So now when we build this model, let's just build it for route 1 first. Okay, and then we can just copy this worksheet over. Okay, make a copy of this and just change the values for the transportation data to route 2 when we want to do route 2 calculation. Okay, so let's just do it for route 1 for now. Okay, so I need to do transportation data. Let me delete this extra line here. Okay. So we're almost done when we get into the computation now. So what transportation data do I have? And now I'm doing it for route 1, so I'm only going to pick out the route 1 data. Okay, fixed ordering cost is 1,000. That's an ordering cost. I'll put it at the end in its own section. Supplier takes a fixed 25 days to get the order ready for shipment. Since the supplier is reliable, we can assume that the 25 days required by the supplier is a fixed number and does not vary. Route 1 takes an average of 20 days with a standard deviation of 8 days. So we can say our transportation time, T, and I'm going to make it formatted just like a regular cell. T, this is transportation time, is 20 days. And then let's change the formatting to match these cells. Then my lead time is going to be more than the transportation time because lead time is the total time. So here I can put processing time is 25 days taken by supplier. And so my lead time will be the sum of the transportation and the processing time because lead time is the time between placing an order and receiving it. And so that's going to be 45 days. Now, my lead time, I'm also going to need the standard deviation of lead time. Okay. And I know that the standard deviation of the transportation time is 8 days. Okay, and there's no standard deviation of the processing time, that's 0. So this is a constant plus a number with a standard deviation of 8. So because this is a constant, my standard deviation of lead time will just be 8. In general, it will be something like this. It will be standard deviation of transportation time squared. Okay, this hat, which is shift 8, means to raise to the power, plus it will be standard deviation of processing time, whatever that's P. Let's say that's 2. Let's say the standard deviation of the processing time is 2. You would square that, and then you would take the square root of this whole thing, and that'll give you the standard deviation of the lead time, because lead time has 2 components, each with its own standard deviation. But what's happening is that the processing time is fixed. It has no standard deviation, and so that just goes to 0. And so your standard deviation of lead time is simply the standard deviation of the transportation time, because this term just falls out, right? Because you add variances, you never add standard deviation. So you do 8 squared, which is the variance for the transportation time, plus you do the standard deviation of processing time squared, which is the variance for the processing time. You add the 2 variances together, you take a square root to get the standard deviation of the lead time. But because this is fixed, this is 0, the standard deviation of lead time is simply going to be the standard deviation of just the processing time. Okay, so that will be 8. Now this is a tricky part of the homework. But if you get this, then everything else will be easy. Okay, then route 2, we have different data, 35 days and 17 days. So I'll just put it here, 35 days and 17 days, and then this would obviously change. So this is an intermediate calculation, so let's make it gray. Okay, and this is kind of like an intermediate calculation or an input. So maybe we should, so we could put in a formula or just type it in. So I'll leave it like an input for now for this problem set, but in general, this could be an intermediate calculation based on the standard deviation of 20, which is 8 here, and any standard deviation that goes here. If this was 0, so because this is fixed, so this was simply 8. Okay, so in general, you can do that formula, square the standard deviations, add them into the square root. But for us, for now, this is fixed, so this is just going to be standard deviation of the transportation time. And this is for route 2. So I'll just put it here so I can easily find this information. And I'll make this text gray so that it's not being used right now. It's just for future use. Okay, move it to the side. Okay, so that's the transportation data. Okay, and then we just have the ordering cost and batch size. Okay, so we have some ordering data. We have S, fixed ordering cost, $1,000 per order, and then we have Q, batch size, which is 8,000 units per order. Okay, and why do we have a fixed batch size? Because that's how many pairs of shoes fit into a container for shipping. Okay, and we want to ship full containers. Otherwise, if we don't ship full containers, the transportation cost of $2, which I should put here, would not be $2, it will be more. Okay, so our transportation rate is $2 per unit. This is assuming I'm shipping full containers, so I have to use this batch size. If I use a different batch size, then this may be higher or lower depending on how many shoes I can fit. If you're not filling the container fully, this will actually be higher because you'll pay for the whole container and you'll not fill it completely, and so your per unit transportation rate will be higher. So that is all the data. So let me color code the inputs. It's a darker shade. So let's make this darker. Okay, so these are all the inputs from the question. Okay. And then in gray are our intermediate type of calculations, just kind of adjusting some stuff about the input data. Okay, now we can go to our model. Now what do we have to compute? We have to compute total inventory cost in dollars per year. So in your slides, you have this big formula. You have the ordering cost, you have the carrying cost, you have the out of stock cost, you have the pipeline cost. So we'll do it all in these 4 steps. Okay. To get our data. So I'm going to start with the carrying cost, okay, because it's I guess the most tricky with some intermediate calculations, and the rest is pretty straightforward. So I'm going to start with carrying cost. You could start with ordering cost, doesn't matter. So let's put here a subsection of our model, carrying cost. Okay, now for carrying cost, if you look at this formula, you have h, small h, which you already have right here, holding cost dollar per year, multiplied by c. Now c is the landed cost. So this slide talks about the landed cost. C is C naught, what you pay to the supplier, plus the transportation cost, because that's the landed cost at your warehouse. So we can do that. Okay, we can compute C the landed cost, which is simply going to be, we did not put what we pay the supplier, so let's do that here in demand data. It doesn't really fit anywhere, but you can just put it here. C naught dollar paid to supplier, and that's $38 per unit. So that's how much it costs us from a supplier to buy a pair of shoes, but that's the price at the doors of the supplier's factory. Then we pay our $2 per shoe to get it to our warehouse. So at our warehouse, when the shoe arrives, it has cost us 38 plus 2 or $40. So our landed cost is going to be 38 plus the transportation expense or $40 per unit. Okay. Now we need to use this $40 in our holding cost calculation. The next thing we need is z-score, which is already there, and then we need SDL. Okay, SDL, which is standard deviation of demand during lead time. Okay, so how much can demand vary during our lead time? And remember, our lead time we calculated right here based on processing time plus transportation time, which is 45 days. So over a period of 45 days, how much can demand vary? A measure of that is called this SDL, standard deviation of demand during lead time. Now to compute that, we have this table in the slides. Okay, so depending on if demand and lead time are fixed or variable. So if everything is fixed, there's no variability in the system, then there's no standard deviation of demand during lead time. If demand is variable but lead time is fixed, then you have the standard deviation of demand times square root of lead time. If demand is variable and lead time is variable, then you have this formula, square root of lead time times standard deviation of demand squared plus daily demand or weekly demand squared times standard deviation of lead time squared. If this D is daily demand, then the standard deviations must be in days. If this D is weekly demand, then standard deviation must be in weeks. In short, the time units for all the variables must be the same. You can't have daily in one place and then the lead time is in weeks and demand is daily demand. That doesn't work. Demand and lead time units must be the same for SDL calculation. Okay, so we have this case. How do we know? Well, we know that our demand has a non-zero standard deviation, 350. So demand is definitely variable. It's not always 1,000 per day. It varies. And if I look at lead time, I know that the lead time has a standard deviation. Why? Because transportation time is not fixed. It varies. It's on average 20 days. The processing time is fixed, but because the the lead time has two components, processing time and the transportation time. If any of the two components is variable, the lead time will be variable because that variable component will make the lead time variable. So our lead time has a standard deviation of 8. Okay, so this is SL, okay, and this is SD, this is small d, and this is L, and we'll use these values to compute this formula. Okay, so L times SD squared plus D squared SL squared. So this will be square root. Now we take the lead time L times the standard deviation of demand squared, SD squared. So we do this to the power 2 plus, okay, actually when I'm raising to the power squared, I want to use brackets to make sure that the raised to power 2 happens before the multiplication. The brackets will ensure I square the standard deviation of demand before I multiply it by the lead time. So always use brackets to make sure the math happens in the right order. Okay, then we can look at D squared and SL squared. So we have daily demand squared, which is this squared, times the standard deviation of lead time squared, and the whole thing is square rooted, and so you get this standard deviation of demand during lead time. Okay, now we can calculate safety stock. This is an intermediate calculation. You don't really need it. You can go directly to the carrying cost, but I like to capture it because I like to compare how the safety stock is impacted by different transportation decisions. So safety stock is just the z-score times SDL. We have already computed SDL, so we just multiply this thing by the z-score, which we also computed here. And so we get the safety stock. So to me, this is like an important intermediate calculation. And so I'm just going to color it to point my attention that this number is kind of important, for me at least. Now I can easily calculate holding, also called carrying cost. So carrying cost, holding cost, they're synonyms. They mean the same thing. Carrying is like you're carrying the inventory. Holding is you're holding the inventory. Both mean the same thing. Okay. And so this, if you look at the formula, is H times C times Q over 2 plus Z STL. Z STL is your safety stock. So we've already computed this part. Z times STL, that's my safety stock. So I have to add to safety stock Q over 2 and then multiply the whole thing by H times C. Now Q over 2 is based on our batch size. Okay. Now, in some problems, the batch size is not given. So what do? So in that case, you use the EOQ formula to compute the batch size. We don't need to do it here because we're already given the batch size. But I'm going to show you, if I did not give you the batch size, then you'll go with EOQ. So what you'll do EOQ formula is kind of straightforward. Let me see if it's kind of given in the slides. If it's not, it's covered in the prerequisite type of courses, but I'm just going to give it to you right here anyway, even if it's not covered. So maybe, I don't know if it's in the slides or not. Let me just give you the formula. So I'll just write out the formula in English first. Okay, so insert, let's do I want to do a shape illustrations. Okay, shapes. Q equals square root of 2 times annual demands times S divided by HC. Okay, so that is the formula for EOQ. Okay, so the EOQ will be square root 2 times capital D, which is annual demand, right here, times the ordering cost S, which is right here, divided by, bracket open, because we want to do the denominator first before we divide. We want to divide just one of the things, H, the holding cost, right here, times C, which is the landed cost, which is right here. Okay. And that becomes 7,211. So if we were not concerned about filling the container, we would be ordering about 7,200 units at a time. But in this case, we will not do that. Okay, in this case, we will not do that because the question tells us use a batch size, which is your ordering size, you order in batches, of 8,000 to fill the container up for transportation economies of scale. Okay, so we're going to use 8,000. So holding cost, okay, is going to be H times C, which is the landed cost, times Q. The Q is the batch size, 8,000 over 2, plus the safety stock. So very easy formula. Okay, we do H, which is 0.3, times C, which is the landed cost, times bracket open Q, which is this batch size over 2, plus the safety stock we just computed right here. And that is your carrying cost in dollars per year. Your annually, you will spend this much money to carry the inventory. And you can formulate the comma. So it's $212,565.98. So this puts a comma after every 1,000. Okay. So this is again an important intermediate calculation. So we can shaded like that. Next up, we're going to do ordering cost. Okay, and ordering cost formula was simple, D times S over Q. So that's annual demand D times the fixed ordering cost S over the batch size Q. Okay, again, this is dollars per year. Okay, and again, I'm going to format it just like this with a comma. Okay, that's 39,000. Then we've done the ordering cost, this box, we've done the carrying cost, we're going to do out of stock costs. So again, we need SDL, and then we need EZ. So that is another number that we can use Excel to find out. Okay, and this is the formula for EZ. It's like a long formula, but we can use it. We can put in Excel to compute EZ. EZ depends on the Z-score, which comes from the cycle service level. So actually, we can just do it right here, up here, convert the Z-score to EZ. And this is sometimes called the unit loss integral. It basically talks about, you know, what it tells you is what is EZ. So let me give you an intuitive explanation. So this formula is on slide 31. So let me go here and see. EZ tells you that in one ordering cycle, or if you order product and then sell, and before your next reorder, in that time period, for a standard deviation during lead time of 1, how many units will be out of stock? Okay, so EZ times SDL actually makes more sense, because EZ times SDL tells you each time you place a reorder and you're waiting for inventory in that time period, how many units will you be out of stock by on average? Okay, so sometimes called the unit loss integral. You don't have to label it like that. So let's compute that. Let's put in the formula, and you can just copy paste this because I give you the Excel formula on slide 31. So you can just copy paste this, and then we'll change the Z value here to what we have. So let's type it in here, and now you want to change the Z to this cell, which is the Z-score cell. I got 2 equal signs to delete 1, and then this Z, you change that to this cell, which has the Z-score, and then this Z also stands for the Z-score, which is this cell. And then you press enter. Okay, so there was some problem with the initial equal cell, so this should now work. So let's see what's causing the problem. Okay, so it's entering it as a text. So let me cut this out. Do this. Okay, so I think the problem is when you copy paste, this is a formatted text and it's not accepting that as a formula. So I'll just have to type it. So let's make it smaller so I can read and type at the same time. So this should be equals norm.s.dist Z value false, don't do cumulative, minus the Z value. Let's see if this much works. Yes, it is working. So now I'll complete it. This times 1 minus norm.s.dist, the Z value, which is right here. And now you need to do cumulative, true, and here it is, 0.02089. Okay. Now I'm going to do an intermediate calculation here, which is going to be units lost sales in units per ordering cycle, and that's going to be EZ times SDL, which we just computed right here, this SDL. Okay, so on each ordering cycle, we are having losses about 174 pairs, right? So this is also a useful number to think about, and that's simply what you've done is done this, the SDL times EZ. Now you have to multiply by K and then by D over Q to get the lost sales cost. Sales cost, so we multiply this number by K, which is how much money we lose if we have 1 unit of lost sales, times the annual demand D divided by the batch size Q. Okay, so this is our lost sales cost with root 1. Okay, and then we have the pipeline cost. Pipeline inventory cost. Pipeline inventory cost is that you own the inventory while it's in transit over ship or rail or truck. And so what is the cost of having money invested in inventory when it is in transit? So it's HC naught. C naught is not the landed cost. It's the money you pay to the supplier because you've not paid the transportation company in advance usually, and so while it's on the truck or rail, the item's value is still the value you pay to the supplier. When it arrives at your warehouse, you have to pay the transportation company, then the value converts to the landed cost. So in your warehouse, the value of items is C, the landed cost. On transportation, the value is C naught. Okay, now if the supplier owns the goods during transportation and you're not responsible for them and your money is not invested in them, this could be zero for you, right? You might say, well, my supplier does vendor managed inventory or something. They deliver goods to my doorstep and only then I have to pay them for the goods. They worry about transportation. They pay for transportation. They own the goods during transportation, and then you don't have pipeline inventory costs. But in the normal usual case, we have pipeline inventory costs because we are doing the transportation as the buyer. Okay, so notice if we take T, which is the transportation time, T is not the lead time. Lead time here is 45 days. Transportation time T is only 20 days because 25 is processing days. So we have to use the 20 days and we have to use C naught, which is right here, the money paid to the supplier, $38. Okay, and we divide by 365 and not 312 days. Why? Because even if it's Sunday and our company is closed, the ship on the ocean does not just put anchor and stop moving because it's a Sunday. The ships continue to move in the ocean, transporting goods. Trucks keep driving, rails keep driving. And so for transportation related pipeline inventory cost, we often assume everything works 365 days a year. If it does not, then you can change the 365. If only your transportation only works, I don't know, 350 days a year, you could change the 365 to 350 or something like that. But usually, for transportation related pipeline inventory cost, we just use 365. Even if you change it by a few days, it's approximately the same answer. This is usually not the biggest cost in this calculation. It's not gonna change your conclusion, so just use 365 because that's the normal way to do it. Okay, so let's do this. So we take H times C naught, which is the money we pay the supplier, okay, times annual demand, right here, not daily demand, times the transportation time T divided by 365. Okay, and that is my pipeline inventory cost. Okay. Okay, so that's all of my inventory costs is right here. This, and this. Okay, so what I'm going to do is in my outputs, copy them here and just do equals. Holding cost is this, ordering cost is this. Just copy them down with an equal sign. Why equal sign? Because if something changes up there, it will change down here. The last cost left is transportation cost, which is really easy. Each pair cost me $2 to transport. And how many pairs do I buy in a year? I buy capital D pairs in a year. So that is my transportation cost. Okay, and I can move it down here as well. And then just copy this all over. Everything is dollar per year. And then you can do your total cost, transportation plus inventory, which is the sum of all of this in dollars per year. Okay. Okay, So that is how we can do our analysis. Usually for the output, you want to color code this to make it look nice, to show that this is very important stuff. Okay, so I'm just going to use yellow and make this whole line bold and yellow. Okay, so this is the output of my model. It gets me the different components of the cost and then the total cost if I use root 1. Okay, now I can just make a copy of this. Right click, move or copy, create a copy. Okay, and just move it to the left, and that's going to be my root 2 now. And I can just repeat all of this for root 2 very quickly. All I have to change is what's different. Root demand does not change if I use root 2. Transportation rate changes to 1. Okay. And then the standardization of lead time changes to 17. Okay. And then my transportation time changes to 35. Okay. Holding cost, this does not change. This does not change. So I think that's it. That should be it for root 2. Wow, and notice my total cost for root 2 is bigger than my total cost for root 1, which is surprising because I'm having my transportation cost. Look at my transportation cost. $624,000 a year with the original route paying $2 a piece. If I go to $1 a piece, this should have to $312,000. It does have to $312,000 as expected, but my inventory costs blow up so much because of this longer time taken on the route that they more than compensate for the savings here, and I actually will be spending more money if I go with the faster route. This is why it's so important. If James Jetson had not taken my course, he would be costing the company on just this one product, more than $100,000, about $150,000 a year, more than his salary. He would just be costing the company per year on just this one product by going to the cheaper route. And this could actually cost even more, because look at your lost sales cost. Your lost sales cost was 135. You were just not selling it. You were just missing out sales of 174 pairs in an ordering cycle. And now look, that's doubled. And your lost sales cost has doubled. Now, if lost sales cost, because lost sales cost is hard to estimate, we are saying it only costs us $20 if we don't have the shoe in stock. But what if your customers start going to your competitors? That means you lose a customer. Customer acquisition costs are much higher than $20 per customer. And so lost sales costs can often be underestimated. So if they are going up in an option, this could also be a red sign that, oh boy, maybe we don't want to go to an option where we have a lot of lost sales, because we could lose customers to competition. Okay, anyway, so now we have done that. Let's make a summary table. Okay. To summarize the comparison between the two routes. And I already built this, so I am going to just use that. And all you do is you copy paste data from here. Okay, so route 1 pipeline inventory cost, you can just say this equals route 1 pipeline. And this equals route 2 pipeline. Okay. Then lost sales cost is above that, so that's going to be, this is going to be this, okay, and then this is going to be the ordering cost is going to be right here, and then the carrying cost is going to be right here, and then the transportation cost is going to be right here. So I'm putting them all on the same page so I can compare them, apples to apples. And then this will just be the sum of these 5 costs. Okay. Oh, I actually put the wrong transportation cost. I put the total cost instead of transportation cost. Now it makes sense. Let's do the same thing for route 2. Fix the formulas. Carrying cost, ordering cost, lost sales cost, pipeline costs, and transportation cost. Okay, so you can see how transportation cost falls, but some of the costs increase, right? So you can do the comparison and see what's happening in route 1 and route 2. So let's go to the homework. What is the lead time if route 2 is used? So lead time for route 2 is simply L, which is 60, 35 plus 25. So why I'm asking you these simple questions? Because a lot of people make mistake. They just think the lead time is the transportation time. So this question 1 getting it wrong tells them where the problem is. So that's why I'm giving you these questions. Standard deviation of lead time for route 2. For route 2, standard deviation of lead time SL is simply 17, which is the standard deviation of the transportation time, because the other part of the lead time, processing time, is fixed. What is the landed cost of each unit if route 2 is used? The landed cost C is going to be right here 39, because it's $38 I pay to the supplier plus $1 of transportation cost, so it's going to be 39. Okay. Sometimes students forget to use landed cost, and which is why this question is there. If they get this question wrong, they figure out, oh, I should not use 38. I should be using landed cost for my holding cost formula. What is the annual inventory holding cost if route 2 is used? Simple dimple. Come down here. Annual holding cost dollar per unit is this value right here. Copy and paste. Okay. Annual inventory holding cost if route 1 is used. We can just use the table to easily copy paste. Route 1 annual inventory holding cost, copy and paste. Oh, it doesn't accept the dollar sign, so I'll just copy paste from here where I don't have the dollar sign. But if you have the dollar sign, you can always just type it out, just a few digits, right? And the same thing is fill out the values. All of them are given. Annual lost sales cost. This is the annual lost sales cost dollar per year. This number for route 1, this number for route 2. So put them in the appropriate question. What is the increase in annual inventory cost if route 2 is selected instead of route 1? It's the total annual inventory cost. Okay, so here I can compute the total annual inventory cost, which is the sum of these 4 components, not the transportation cost, just the inventory one. Okay, and I can do the same thing for route 2. Okay, oops. So you can see some of these for numbers. And so what's the increase if you go to route 2? The increase in the above is going to be this minus this. Oops, not that. That minus that. And so it increased by 456,000. Notice our inventory costs go up by almost $500,000. We only save $312,000 on transportation costs by going to the cheaper route, and so net we lose money. So 456,370.14. Question 9. Select all statements that are correct regarding the cost calculations. Transportation cost for route 2 is half that of route 1. That is correct. If you look at transportation cost, route 2 is half of route 1. These may be in a different order for you, to just read the statement and check your numbers here. Lost sales cost for route 2 is more than twice that of route 1. So lost sales cost of route 2, it is more than twice, because if this was 140, this would be about twice. This is less than 140. So 135 times 2 point something, more than 2, gives you 280. So if you divide the 2, it's more than a factor of 2 bigger. So this is true. Pipeline inventory cost is larger for route 1. Nope, it's actually smaller, so that's not true. Ordering cost is larger for route 2. Nope, they're equal. That is not true. Inventory holding cost for route 2 is 10,000 more than route 1. Nope, that is not true. It's the difference is more than 10,000. Okay, select all the statements that are correct conclusions from the analysis. So from all this analysis, what are the correct conclusions we can draw? Route 2 is risky as it more than double lost sales cost. Lost sales are of particular concern as high lost sales can also lead to future loss in revenue from customers switching to competitors. That is exactly true what I was talking about before, because the lost sales costs are estimated just based on the gross margin lost on the pair you did not sell. But there could be future consequences. Customer is not happy, they couldn't find their favorite shoe at your store, and they go to a competitor and they never come back to you. So increase in lost sales is risky. It adds future risk to us. Since demand is the same, the increase in inventory holding cost for Route 2 is due to the increased lead time and increased variability in the lead time. Okay, now look at the inventory holding cost formula right here. Okay, Q is the same for both routes. Landed cost is different. H is the same for both routes. And SDL is different because of lead time and standard deviation of lead time. So this is almost correct. It is true that the increase in the inventory holding cost is coming from the increased lead time and the standard deviation of lead time, but it's also coming, yes, that should be true, because the landed cost is lower, which is actually helping us, but the increase is coming from the increase in lead time and the increase in the standard deviation of lead time. Okay, the landed cost is actually helping us with Route 2 because Route 2 has a smaller landed cost. Okay, so this is correct. The increase in the inventory holding cost is coming from the lead time and the standard deviation of lead time changing, which is why we need more safety stock. If you compare the safety stock, you'll see a big change. Safety stock is this much here, and if you look at the Route 1, the safety stock is this much here. Okay. And then this safety stock, costs money to store, which is showing up here, right? So let's look at options right. So these two options seem correct. Route 2 lowers transportation cost a lot, which is true. We should select Route 2 as James is working on transportation and you should not care about other costs. That's totally false. As a logistician, you have to worry about total cost. You can't just reduce cost in one area and increase cost in other areas and say my job is done. That's silly. Route 2 is superior in all aspects? Not at all. It's only superior in transportation costs. Route 1 is superior in reducing inventory costs. James will select Route 1 as keeping total cost low is preferable to just focusing on the costs. Yes, James is smart. He's my student. He's going to select Route 2. He's going to lower total logistics costs, not just focus on one part of logistics costs. James was correct to examine inventory costs because Route 2 savings in transportation costs are offset by the increase in inventory costs. Totally correct. We save on transportation costs in Route 2, but then we use up all that money and more in increased inventory cost. And so James was correct, and he's very smart to calculate the inventory costs. So that is it for this homework. I went a little bit fast at the end for these, but hopefully it makes sense. If not, you can either pause and rewatch the video or contact me and I will explain this to you.